Let us do another example of this here. Remember, the more you practice with any kind of subject, the better you will become at it. So the most important thing is to do more of it. Right, let's do example 2. It says here the following reaction takes place in a 250 centimeter container at 400 Kelvin. Now the temperature, they're just giving it to you, but really we don't really need it right now. Now, can you see they're giving us 250 centimeter cubed? So this is volume. But one thing you need to remember is volume is always in decimeter cubed. So if they give you centimeter cubed, you will need to convert it to decimeter cubed. Right, so the reaction is 2NO plus Br2 giving you 2NOBr. And again, you see the reversible reaction arrows which tells you equilibrium. Right, the reaction initially contains 0.25 moles of NO. So we have 0.25 of NO in the beginning, and you have 0.1 moles of Br2. When equilibrium is reached, it is found that 0.2 moles of NO remained. Calculate the concentrations at equilibrium. Now they're telling us that at the end, or when equilibrium is reached, you have 0.2 moles of NO afterwards. Now, NO is the reactant, it is not the product. So they are basically telling us how much reactant we have left at equilibrium. So they didn't give us any information of product, they only gave us information of reactants, which we will use to work out the product as well. Right, so let us start with this table. The first thing in the table is to do R. Now R, you're just going to take all of the reactants and products and make a table out of it. And don't forget, it needs to be balanced. So you need those coefficients. Right, the next thing after you do that is to use the initial moles. Now the initial moles, they told us for NO, you started off with 0.25, right? And then for Br2, they said we started off with 0.1. Okay, now for product, obviously they didn't give us any information, and we know that in the beginning of the reaction there is no product because the reaction didn't yet begin. So because there is no product moles will be 0. Right, the next step is to do the change. Now the change is actually simple to do because all you have to do is look at the coefficient and then add a minus or a plus. Right, so now the coefficient of NO is 2, and NO is the reactant here, and reactants always decrease, so it has to be a negative. So you're going to say negative 2, and obviously it's in terms of x, so it will be negative 2x. And then Br2, the coefficient is 1, and it's also a reactant, so it will be minus 1x or just minus x. And then for the product, 2NOBr, the coefficient is 2, so it will be 2x. And since it's a product and product increases, it will be positive 2x. Right, so now that we have the change, we can use it now to work out all of the rest. Now, another important piece of information that they gave us is they said that 0.2 moles of NO remained, which means at equilibrium, after the reaction started and happened, you had 0.2 moles of NO. So the moles at equilibrium is 0.2 moles. Okay, so now for NO, we have basically all of this information. For Br2 and NOBr, we don't have enough information. So because we have the most information for NO, we're going to use this to work out X. And remember, it's always this plus this equals to this. So we're just going to take everything in the table and we're going to write it in a equation kind of style. So we're going to start with 0.25, so it's going to be 0.25, and since this is a minus, we're going to put it as is as a minus. We're not going to change it into a positive. If it's reactants, it will always be negative. So 0.25 minus 2x, and that is equal to this concentration at equilibrium, which is 0.2. So can you see how we get X? We are just basically taking everything from the table from the beginning going down, and we're making it into an equation. We're just saying this plus this equals to that, or this minus this equals to this. Right, now that we have this formula, I'm not going to go into solving formulas. You guys know how to do that. You're going to solve for X, and you're going to get an answer of 0.025. So this is what X is equals to. Right, so now that you know what X is equal to, you can substitute it where you see X, and that will give you basically the concentration or the moles at equilibrium. Right, so let's start with Br2. You have here a minus X, so because X is 0.025, it's going to be negative 0.025. Okay, and then for the product 2NOBr, you have positive 2x. So since you're dealing with positive 2x, you're going to say 2 times 0.025, which will give you positive 0.05. And this is the moles of equilibrium of NOBr, actually the change. Right, now once you have the change, you can work out the equilibrium moles. So you're going to say this minus this will give you this. So you're going to say 0.1 minus 0.025 will give you 0.075. So you're basically just working from the top of the table and you're working downwards. So you're going to say this plus this gives you this. For reactants, this minus this will give you that. So you're going to say here for the product, 0 plus 0.05 will give you 0.05. Okay, now we're done with the most complicated parts. Now it's just left with the easy part. So you have all of the moles at equilibrium. And now to get the concentration of equilibrium, we are just going to use the formula C is equals to N over V. So we're going to take all of this moles divided by the concentration, by the volume, and this will give you equilibrium concentration. Right, so let's start with NO. You have 0.2 moles and the volume they gave us is 250 centimeter cubed. Now remember, centimeter cubed, we need to change it to decimeter cubed. And how do you do that? You multiply it by 10 to the minus 3. Okay, so you're going to say 0.2 divided by 0.25, which is converted to decimeter cubed, and that will give you 0.8 moles per decimeter cubed. Right, then you're going to do the same for all of this. You're going to say this moles divided by 0.25, and that will give you 0.3. And the same for the product. This moles divided by 0.25 will give you 0.2. And remember, the volume is the same for all. So you're going to divide all by the same volume, which is the same number. And this is basically it. Right, let's do one last example, but I want you to do all of the examples. Right? Okay, so example 3, it says here 9 moles of hydrogen iodide is sealed in an empty 2 decimeter container. So again, 2 decimeter cubed, that is the volume, with 2 moles of H2. When equilibrium is reached, 5 moles of HI are found in the equilibrium mixture. Calculate the concentrations at equilibrium. So they're telling us in the beginning, we had 9 moles of HI. Now if you look at this formula, can you see HI is actually the product? But then they said you have 5 moles found at equilibrium. So you had 9 moles in the beginning, and at equilibrium you have 5 moles. Can you notice here that the HI, which is supposed to be the product, actually decreased, which is telling you that if something is decreased, it cannot be a product. It has to be a reactant, because only reactants decrease and products increase. So even though we are looking at this formula of hydrogen plus iodine giving you HI, this reaction is actually happening reverse. So it's actually the reverse reaction that is happening. It's actually HI giving you I2 plus H2. So even though it's written as the forward reaction, it's actually the reverse reaction that's happening. And H2 and I2 is now the products and HI is the reactant. Okay, so don't take it for granted that whatever you see is exactly what is happening. Sometimes they can confuse you, like in this example here, where you need to look at the actual values and see what is happening. Right, so let's start with the first R of the table, which is just writing the reaction. So you have H2 plus I2 giving you 2HI. Now you can write it like this, or you can write it the other way, where you making HI the reactant and H2 and I2 the product, but I just wrote it as straightforward. But remember that this one here is now the reactant. Okay, so let's start with I, the initial moles. Now initially they told us that you have 9 moles of HI. So I'm going to fill here a 9. Then they also told us that you have 2 moles of H2. Now H2 is supposed to be the product, isn't it? And normally the product is 0 at the beginning. But since they have mentioned to us that you have 2 moles of H2 at the beginning, we are going to fill it in. So if they don't tell you anything, it will be 0. But if they do tell you, you will just use that value. So for H2, they told us 2 moles, so I'm putting 2 moles. But for I2, they did not mention anything, so I will put a 0. So just remember, if a product is not mentioned in the beginning, it means you have 0 initially, 0 moles initially. If they do mention it, like in this one with hydrogen, it means you just have to put the value that they mention. Right, now it's coming into change, and with change we're going to do it in terms of x and a plus and a minus. Now remember that this HI is actually the reactant and H2 and I2 is the products. So for the products we're going to put a plus sign, and for this one we're going to put a minus sign. So here you have a coefficient of 1, so it will just be plus 1x or plus x. Same with this one, it's a coefficient of 1, so it will be a plus x. And then this one is the reactant, so it's going to be a negative, and the coefficient is 2, so it will be minus 2x. Right, now we need one more missing piece of information so we can actually calculate x. Right, and then what they told us is, they said at equilibrium you now have 5 moles of HI. So they're telling us the moles at equilibrium of HI is 5. So because now we have all of this information of HI, we can use this here to calculate x. So we're going to take it directly from the table. You're going to say 9 minus the 2x is equal to the 5. So you're always just working from initial right up to q, and you're just writing it as is in terms of an equation. And from here you are going to solve for x, right, and you will get an answer of 2. So x is equals to 2. Now that you have this, you can just substitute it into the table, and from there you can work it out. Right, so x is equals to 2. Here you have a plus x, so you're just going to say plus 2. Here you also have a plus x, so it will just be plus 2. And then we're going to work downwards and just add or subtract whatever is here. So you have initially 2 plus 2, so 2 plus 2 will give you 4. Remember, you're just working downwards. Then here you have 0 plus 2, which will give you 2. Right, now that you have all of the moles at equilibrium, now it's the easy part of working out the concentration, and all you have to do is take the moles divided by the concentration, and that will give you equilibrium concentration. So again, you're going to say C is equals to N over V. The volume they gave us is 2 decimeter cubed, so we're going to divide all by 2. We're going to say 4 divided by 2 will give you 2. 2 divided by 2 will give you 1 mole per decimeter cubed, and 5 divided by 2 will give you 2.5 moles per decimeter cubed. Right, and that's it.